Hello everyone, today I'm going to walk through the code behind my senior project that has taken the better part of a week to get going and it has been a rather miserable experience, but now I've got something I'm very proud of. So let's get into it. So the code itself is not very exciting, in fact it's quite terrible. I wouldn't be surprised if someone puts it in a YouTube video called Programming War Crimes, and yeah, that is a series on YouTube. So I could go through it, I might, but you're probably more interested in what it actually does. So let's show that in action. I've got a video here of it running. With the screen recording software, it slows down the code significantly, so it shouldn't take this long when I'm actually running it. I think it's just an issue of my laptop getting overloaded. At the moment, you're seeing it run at 400% playback speed, so this is quite a bit faster than it was in real time. This is to make sure the video doesn't drag on for an hour, and I will try to explain everything that's going on, since there are a lot of moving parts here. You can see in the bottom right it says session complete, and I have that print when the code is finally finished. So the project itself is to make a low-cost alternative to a portable oxygen supply. So if you have breathing issues or whatever, you would have a canister that you bring around with you to supply oxygen. So the senior project that I'm working on is to make a low-cost alternative, and the solution our group is using is called zeolite, which are, you can sort of think of them as little bitty marbles, and they filter out the nitrogen in the air, leaving you just oxygen. So the project has to have a variable oxygen supply. So in the air it's normally around 21%. So if the desired value is 60%, the system we build has to be able to supply it to at least 55% concentration and no more than 65% concentration. So you can see on the screen there it's 20.7, which is standard for unmodified air. You can see the numbers are displayed in what's called 7-segment displays. This is the same thing your digital alarm clock uses. And this is a cheaper alternative to just showing a number, especially one that has curves in it. We've learned to recognize what these bars look like. 0 is a ring all the way around. 8 is a 0, but it has a link in the middle. 1 is just 2 lines up and down, and you get the point. The problem with this gauge is that it doesn't know how to talk to a computer. So for the first few months of this project, our goal was to have something that communicated directly with the computer. And it was at Thanksgiving, right after Thanksgiving rather, that I finally realized that it just wasn't working. It had too many issues, and it was really better suited for someone who's studying computer science or whatever. Obviously, I'm doing a lot with computers already, but this was still above what I was used to. So I had an idea to read our oxygen meter with our webcam and translate that to a number that the computer can understand. That was my challenge, was to not only tell the computer, hey, the gauge is saying 20.7, but to have this run at regular intervals, since we need to show that the oxygen concentration is stable over time. So with that explained, I'm going to go over the main parts of the code, not all of it, because there's a lot of just technical stuff that you really don't care about, like telling the computer, hey, switch from the console to the camera. And yeah, that has a chunk of code. It's super exciting. So the big players here are the Python programming language, which I'm running in an application called Spyder, S-P-Y-D-E-R. We're also using MATLAB, which is also Python-based, but it's specifically meant for math applications, graphing and stuff. And then lastly, we're using the camera app from the Microsoft Store, which has given me its own issues, but I like it because you can just hit the space bar and it takes a picture for you. And that's critical, is being able to have an automatic input. You don't need the user to come over and press the space bar, because I can use the code to simulate pressing the space bar. So I'm going to play the video of the code running again, and we'll skip over some of the boring parts and the loading times, and I'll show you how everything works. The first thing it does is it opens a text file where I have instructions for MATLAB. MATLAB is being used to actually read the numbers off of the image. I was trying to get this whole thing to run in Python, but I just couldn't get things to work. And since I have access to MATLAB for free through my university, I just thought I'd try that, because I was really running out of options. And believe it or not, it actually worked without much effort, relatively speaking anyway. So that's why I have this sort of ad hoc mess of switching between Python and MATLAB. Not ideal, but it is working, and that's what matters. Opening the text file didn't take very long, but now we have to wait on it to actually open MATLAB. This is only done at the beginning of the code. Once it runs through a loop and goes to read another picture, MATLAB is already open, so we only have this huge load time at the very beginning. There's also some buffer period built into the code so that it doesn't try to proceed too early, which is something I had a ton of issues with. So you can see now that I went to the Start menu and opened up the camera app. This is a weird side effect of this app coming from the Microsoft Store. If it was any other application, I could just open it from Run, the Windows key plus R, or launch it through Python directly. But this was the price of getting that automatic spacebar pressing, which I already talked about, and the normally very fast load time compared to some of the other webcam softwares. The next thing it does after it takes the picture is it first rotates the image 90 degrees clockwise and then crops it so that you're only seeing the part on the screen. So in this case, it's going to be that 20 point something. After that, it switches the window over to MATLAB and pastes the command to make MATLAB do its magic. For whatever reason, it was especially slow this time, and you can see in the Python output that it says looping until idle. So it's waiting for MATLAB to be finished for it to not say busy. Really cool. For it to not say busy in the corner. So here's the exciting part. You can see text 20.6. Sometimes it doesn't always get the decimal point, and it doesn't always get the number that comes after the decimal. So I've got a little bit of code to fix those issues if they occur. If the number after the decimal doesn't show up, I just assume it's a 5 and we call it good enough. The last thing it does is it logs the percentage measured on the O2 meter and the time it took to make that measurement to 2 separate text logs. When it runs through this loop a second time, the new percentage and then the time elapsed since the very start will get logged again, so that we get a log of 20, 20, 24, 27, and then the time log is the time from the beginning to that measurement. Seriously, this again?
I can't be bothered right now.
Once everything's done, it's time to do engineer's favorite activity, graph it in Excel. And that's really about it. Without the screen recording software, it should go a lot faster. I was getting around 30 seconds per loop, which was my goal, and overall, I'm really happy with how this works. It's ugly, but it does the job, and that's all I was really after.
Is anyone else getting hungry?